transformed into the electricity. The process transformation is the fuel energy is transformed by combustion into calorific energy. The calorific energy is converted in the turbine expand into the mechanical energy. And mechanical energy is transformed into electrical generator by means of the energy.
This is a basic diagram of the thermal power plant. In this, we can see first the boiler. In the boiler is the entrance of the foil, the fused foils. In this, this is going to heat water. The water or any other fluid. Most common, water. The water is going to heat in a high temperature, and this produces steam. The steam is going to conduced by pipes to the turbine, and the turbine is going to move the axis that is the same axis of the generator. The generator produces electricity. But when the hot water is condensed, enters cold water that is going to cool this hot water to renew the cycle.
Okay, the conventional thermal power station. They use the heat the source of energy from fossil fuels, natural gas, and petroleum products. The fuel is burned in a boiler generating a heat energy that is used processing which drive the turbine generator, mechanical energy, and finally generates electrical energy in the alternator. Okay, the essential construct part is a boiler room, machine room, and distribution room, and the addition energy exchangers. In environmental, these are benefits is emission of atmospheric pollutants, sulfur dioxide, nitrogen oxide, and solid parts. The gas center, gas turbines have the advantage that they do not pollute and have created a efficiency. The basic elements of turbine are the compressor, the combustion chamber, and gas turbine. Gas turbine cycles are classified open in the closed and open cycles, depending on the turbine gases being evaporated directly into the atmosphere or recirculate by passing them in the compressor through heat exchangers.
Okay, the most important functions in the heat exchanger in these thermal power plants, there are four. The first is the economizer. The economizer is going to be located between the boiler and the pipes that conduce the liquid water. Because the economizer has the purpose to improve the performance of this operating cycle. After, we can find the evaporator. The evaporator is located after the steam of the turbine, because the turbine is going to condense and is going to be transformed in liquid. The superheater is located near to the hottest part. The hottest part in this diagram is the boiler, because the boiler is going to bring the energy to heat this foil. This obviously elevate the temperature. And the reheater is localized after the condense, because this doesn't want to decrease very high the temperature, because requires more energy to heat again. In this image we can see basic diagram, that is the modular A-sharp S-G. This modular has a horizontal path of the heat. The heat fluid is going to conduce in this way, and the first modular that find is the superheater. The superheater is going to increase the temperature. After this, we're going to find the evaporator. The evaporator is going to decrease the temperature, because it's going to conduce to the economizer. The economizer bring this energy and reduce this required energy to improve the performance. After this, we can see other evaporator to again go to the economizer. The final modular is the chimney, and in the chimney goes to the steam to the atmosphere.
And the last topic that I would want to explain is the conventional thermal central operation. Like my partner says, have three main sectors: the boiler rooms, machine rooms, and distribution. But the most important is the boiler rooms, that give us the stream that is necessary to move the turbine at the final state. There are two types of circuit. The first one, the full bias, that depends on the fuel that we're going to use, and give us the characteristic of the discard zone and the materials that's going to be used to process this fuel. Like example, the coal. The coal is a economic as well as transport mineral, but the warehousing have to be so big to contain all this mineral. Also, this mineral is going to use other types of materials, like bands and a room that crushed the mineral to be cooked. It's all, well, the full gas burn the increase the temperature on the boiler, and this increase the temperature in the stream that gonna be have the change of stream in a movement of turbine. The boilers. The first one is the boiler controlled circulation. That the main idea is the forced convection that it make. This type of boilers use other type of bombs to increase the velocity of the flow. And there were circulation boilers that use a natural convection between the both streams, the holder and the hot. This video versus all. First one, the mineral is put in the plant and moved by bands, like I said before. After that, this increase the temperature of the boiler, and with that, increase the temperature on the head exchanger. this give us now a new stream of vapor to move the turbine, and with that, when the stream is finished, the move it start to decrease his temperature with a polar sector that is located next to the turbine. And with that, we can reuse the streams. With the movement to the turbine, give us the electricity.